All right. This will be kind of more chaotic than the very coherent speech we just heard. So just try to keep up, and maybe you'll find a nugget or two in there somewhere. I'll be talking about some learnings that we got from tuning vector search systems up to 2 terabytes of the index size. So I don't know what happens after that. I'm looking forward to find out, I guess. The first thing that we see that it's a problem is that you optimize the wrong thing, right? So, for example, you can choose this as your framework, your map of trying to figure out the shape of your system, right? So you are doing variously good on cost, precision recall, latency reliability, complexity, and compliance. And then the question is, okay, on which of these dimensions should you improve? And if you want to get promoted, it better is a direction aligned with what your boss wants. So, you should find that out first. So, your boss might say things like this. We want to sell more products. We want to improve support ticket resolution time. We want to enable product teams to make data-driven decisions. These are not super useful for us, right? We need to add some detail. And after that process where you have to be friends with your boss and with your product manager and all these people, hopefully you'll have a sentence that captures some kind of metric that can be translated to one of those parameters of your information retrieval system. And then you'll basically be able to identify the lever, one of those levers, that if you move it, then this contributes to that metric, right? And then you start to actually think about the solution. Now, if you are just wondering in the community, like, what are people actually struggling with in terms of their own information retrieval systems, I do this office hours stuff on LinkedIn, and I poll people for, is it, what stands between you and the next production deployment of vector search? Relevance comes out on top, but there is also like cost, latency, throughput, which are sort of interchangeable, right? You can pay for more throughput or for better latency sometimes. So this is kind of like cost, latency, throughput is one cluster, and relevance is the other one. So I would just share some stuff for those two. Okay, there has been this sort of hype on Twitter that we shouldn't do evals anymore. I don't know if you have noticed that. Like, no more evals, only monitor stuff in production, and, YOLO. We still believe that evals are good. It's good to split them into kind of the sane part that you like generate and understand, and okay, this is what our users should be doing. But then you also monitor and you pull in some crazy stuff from what the users are actually doing, and then you just combine those together, but maybe don't throw them into the same pile because it's going to be very hard to pick apart the root causes. Then I see lots of people solving certain problems in the wrong place. So like, hey, we just learned how to do re-ranking, so we are already re-ranking 1,000 things and paying a lot for compute and a lot of latency, but maybe let's increase it to 2,000 candidates, right? So like at some point you have to, again, take a step back, figure out what's the right place to solve problems. Now, as we talk about context engineering, you should think about context which is not text. So we are all obsessed with text tokens, right? Like it's all about that. But actually most of your data may not be strings, right? So you have to figure out how to bring that information in. For any kind of text to query, kind of query understanding that generates an OpenSearch query, I suggest having very opinionated and small and few templates that you are populating by the query understanding module, and you can call these templates tools, right? If you are building an agentic system, then the templates are tools. You should fine-tune embeddings. You should use late interaction, so multi-vector representations. You should look into DSPY if you haven't yet, and superlinked. And finally, you should stop pooling vectors. So if you have, let's say, document vectors, this means you are aggregating your vectors across all the tokens in a document. Stop doing that. Because this basically destroys the information. And I have a quick illustration for that. So we have maybe all seen this example of like, this vector represents king, and this vector represents queen, and then if we subtract man from king and add woman, we get queen. And you can kind of replicate this, and it's cool, right? This is the vector arithmetic. Except this is like about as complicated as an example you can make up that still works. Like if you try to push this kind of thing one step further, it just falls apart. And I have an example for this, which is like yellow high heels, cheap beach sandals, and red fancy shoes, 3 strings. You make embeddings, you take average. And then the word footwear will embed over here, which is okay, like it's all footwear, it's like reasonably close to the average, okay, fine. Except clothes will be closer than footwear, which is already kind of breaking this mental model we have about how these aggregations work. And then the string skirts show flashy will be the closest one to the dot. Okay, and by the way, you can reverse engineer the strings from the embeddings. So you can kind of explore this kind of stuff and really try to build a good mental model. Okay, and the last bit I have is, is the latency. And I think, working with a bunch of different vector database providers over the last few years, I think there are basically 2 types of vector-enabled databases. Either they are optimized for full scans, but this means they have to process a lot of data for each query, and so the price is driven by the number of queries and the selectivity of the filters, and like namespaces that are used to partition the queries. Or they have some kind of, let's say, graph-based index optimized for looking at narrow neighborhood in the vector space, and then pre-processing and re-ranking that neighborhood. Basically, that's it, right? These are very 2 distinct things that are available. And the second type is kind of driven by the memory cost, the price there. And so...
how many slides do you still have?
Like two more slides, sorry. Oh, yeah. Yes. I'm almost finished. You should benchmarks, reads and writes. Nobody publishes benchmarks that combine read and write access. And if you have any kind of production database, you will want to probably eventually write to it. So we have to do things like swapping databases, like creating an index and then swapping traffic to it. Basically, reading and writing doesn't work at the same time. And last point is, I got flamed on LinkedIn a bunch for putting time into vectors. And people don't understand why you would want to put metadata into the embedding. Go read the fine print of your search provider. For example, this is OpenSearch, but it's all, I love all these providers, and we work with all of them, and they're great. But if you try to do metadata boosting together with your vector search, you'll be kicked into full scans. The approximate nearest neighbor index, that's the fast way to search vectors, no longer applies, right? So you either do approximate nearest neighbor search and re-ranking on the metadata, or you are kicked into full scans, which eat a lot of compute and are slow. So this is the kind of stuff that matters. I almost vibe coded the demonstration, but Claude Code got stuck in some authentication loop. So you will have to, we'll have to trust the documentation of OpenSearch on this. And this is the kind of questions you should be asking your vector search provider.
Thank you.